Welcome to our KNX training. Introduction of the application. With this video, we would like to introduce a solution based on KNX technology for demand-oriented, energy-efficient room temperature control. Commissioning is carried out with the manufacturer Independent Engineering Tool Software, ETS. Before the KNX-based individual room temperature control is explained and illustrated step by step, the basic structure of the heating circuit of a heating system should be explained. Water is the heat transfer medium. The water is transported from the producer, in this case, the boiler, to the respective heating surfaces in the rooms. The heat is then released into the rooms. These can be radiators, panel heating, underfloor heating, or ceiling or wall heating. For the required heat to reach the heating surfaces in the rooms, a circulation pump is required on the flow pipe. The cooled water is returned to the generator, the boiler, via the return pipe. For demand-oriented, energy-efficient individual room temperature control, thermal actuators are required at the respective heating surfaces. The valve's opening or closing regulates the hot water's flow rate and, thus, the heat output in the rooms. Thus, each room receives the desired individual room temperature. The control of these thermal actuators is realized via a corresponding KNX-based actuator technology. This guarantees a customized temperature control. The comfort, the usage behavior in the room, and the energy efficiency are optimally coordinated. The rooms are only heated to their comfort temperature when they are occupied. If the rooms are unoccupied for a short or longer period, the temperatures are lowered differently accordingly. When the windows are open, the room temperatures are reduced to such an extent that frost protection of the building is guaranteed, but no heating power is wasted. Which KNX components are needed for room temperature control? A room thermostat or a room control unit is always required in the room. The beautifully designed, multifunctional touch control TC5 is used for this purpose. This has a 5 inches color touch display and is available in black or white. It can be installed horizontally or vertically. The display changes accordingly. The touch control has an internal room temperature sensor. This is included in the temperature detection in the application. There is an LED-colored light strip as an orientation light or for signaling alarms. This display is used in the application to indicate the heating mode. The desired set point temperature is set via the room control unit or the room operating mode is changed. In addition, the current room temperature is displayed, which can also be detected in the room control unit. Compared to a thermostat, a room control unit has the advantage that in a cross-functional system with KNX, all functions in the room can be controlled by one device, and various room and sensor values can be displayed at the same time. In addition to the room temperature control described here, this includes functions such as switching, dimming, tunable white, colored light control, or human-centric lighting. This includes the control of solar protection, other HVAC applications such as floor heating, ventilation systems, VRV, VRF applications are realizable or also a scene control, various logic functions, timer functions, alarm handling and much more. The heart of this room temperature control is the thermal drive actuator. There are two models for different mounting variants to choose from. The N605D41 thermal drive actuator is available as a DIN rail mounted device for installation on a DIN hat rail and an electrical distribution board. This is a 6-fold thermal drive actuator for noiseless control of the thermal actuators of up to 6 heating or cooling circuits. The N605D41 also has a direct operating level on the front of the unit. With this, the valves can be opened and closed manually, and the installation can be checked. Furthermore, the N605D41 indicates a mains voltage failure, overcurrent, or short circuit error via 6 error LEDs on the front of the unit. and the RL605D23 thermal drive actuator is available as a compact, modular device for decentralized installation in the control module box AP118 or in the room control box AP641. This makes it possible to install the actuator on the wall, in parapet ducts, in installation columns, on raised floors, or above a suspended ceiling. The modular RL605D23 is a two-fold actuator for noiseless control of the thermal actuators of up to 2 heating or cooling circuits. Both actuator variants can be used to control both de-energized closed and de-energized open valve drives. Both actuators are basically identical in their application and are considered equally in the following application description. In contrast to the N605D41, the modular thermal drive actuator RL605D23 has no direct operating level or error display on the unit. Why do the thermal drive actuators form the core of the following application description? In addition to their core function of controlling the thermal actuators, the thermal actuators have room temperature controllers that match the number of channels. Their control value outputs can be linked directly, internally, to the channels for valve control. This means that communication via the KNX bus, using group addresses, is unnecessary. The application includes various safety and override functions for service and maintenance. To protect against calcification, the valves can be flushed. Furthermore, various information about the heating or cooling demand can be transmitted to a primary system. This ultimately serves to save energy. The calculation module offers a very interesting possibility. Different temperature values, which are detected at different points in the room, can be weighted individually. As a result, a very representative measured variable is used as the actual temperature in the room temperature controller. This value can also be transferred directly internally. The temperature should be lowered for energy-efficient room temperature control when rooms are not occupied. This requires a presence detector in the room. We use a presence detector wide from the wide portfolio of ceiling-mounted multi-sensors for this purpose. Motion and presence detection are available with all device variants. At the same time, temperature detection is also used in the application. Since this measurement on the ceiling is not always optimal, depending on the technical conditions, the detected temperature is later weighted with the temperature detection from the room control unit via the calculation module in the thermal drive actuator. In order to lower the room temperature to a minimum set point when the windows are open so that only protective operation is effective, the status of the windows is evaluated via window contacts. The status of the window contacts is detected via potential-free KNX binary inputs and transmitted to the KNX bus. Depending on the installation and mounting options, DIN rail-mounted devices or flush-mounted devices, e.g. a push-button interface, are used here. The schematic structure of the room temperature control is shown below. The central component is the controller. A PI controller determines a continuously control value from various input variables. This control value is converted into a binary signal, on or off, via pulse width modulation. The thermal actuator is then energized or de-energized via a semiconductor output, thus opening or closing the valve. This process and the control loop occur entirely in the thermal drive actuator. The controller requires the actual temperature in the room as input variables. It also needs a set point temperature. This is the default value to which control is to be performed, and a room operating mode can be set. A distinction is made between the 4 different room operating modes: comfort mode, pre-comfort mode, or standby mode, energy saving mode, or night setback, and protection mode. These are set depending on the room usage. Each room operating mode is assigned a suitable setpoint temperature during commissioning. A room control unit supplies these 3 input variables. Presence detection is required for switching to the room operating mode comfort mode. A presence detector provides this information. Since the presence detector is also equipped with a temperature sensor, this measured variable is also considered. To detect the actual temperature as accurately as possible, several measuring points in the room should be evaluated, and the values of the different measuring points weighted accordingly. Due to drafts, detecting the actual temperature via a room control unit near the door can be inappropriate. The lighting or also heated or cooled ceilings can influence the measured value of a presence detector on the ceiling. Using the calculator module in the thermal drive actuator, both measured values can be weighted in a ratio of, for example, 50-50, and the result transferred to the controller. To switch to the room operating mode protected mode when the windows are open, you need the window status. In principle, evaluating the presence or the window status is optional. This illustration shows a typical room installation for controlling the thermal actuators in a radiator heating system. This is the basis for the following project commissioning. In this example, an office room is heated. The KNX DIN rail devices, such as system devices for the KNX power supply, KNX routers, KNX interfaces, line couplers, gateways, etc., and the corresponding actuators, controllers, and input modules for further functionalities are located in an electrical installation distributor, which is installed in a plant room, for example. The room control unit TC5 is usually located in the entrance area of the room, next to the door. The presence detector wide is mounted on the ceiling in a good detection area of the workstation. For the actual thermal drive actuator, the modular version, RL605D23, is used in this example. This can be installed with the control module box, AP118, which is available as an accessory for decentralized installation, in a dado trunking under the window. There, the thermal drive actuator is in the immediate vicinity of the thermal actuator, and there is a short wiring path for the load side connection. The individual components communicate via the green KNX bus line. In summary, an overview of all KNX products used with their order numbers, dimensions and product designations. I would like to introduce the operation and display options of the room temperature control. Let's start with the function page for heating control. In the center of the display, you can already see the currently measured room temperature. Using the slider, you can set the desired room temperature set point in a range between 16 degrees Celsius and 26 degrees Celsius in absolute values. As soon as the slider is moved, the temperature display changes from the actual value to the set point value. You can also see the set point value as a numerical value and change it using the two buttons on the left and right. This setting is effective for comfort mode when the room is occupied. In this range, it is possible to switch between the operating modes in manual mode. In the case of a heating function, the set point temperature would therefore be lowered accordingly the parameterization with the ETS for standby and economy mode. When the protective mode is selected, a fixed value of 7 degrees Celsius is used as the set point. In the lower area, there is an on-off button to deactivate the operation or to switch the controller on-off. This group address is not linked to this application. All these settings can also be blocked individually by parameterization with the ETS. If the heating value is open, this can be indicated with the red LED color strip on the device. The Home button on the top right brings you back to the main page.